And we're going to go through each term. So what does density mean? Well, density is the amount of mass within a given volume, a ratio of the mass to the volume. That's what it's a measure of. Mass. Remember, mass is the amount of, go back. Mass is the amount of matter in an object. How many bits make you up? If you pull a hair out, then your mass has declined slightly. There's slightly less bits of you. If you eat lots, then your mass will increase. The amount of matter in you will increase. Volume is just the amount of space an object takes up. So each of you is taking up an amount of space in the room, and that's your volume. Grams, just a unit for measuring mass. Cubic centimeters, the metric unit for measuring volume. So each of these tiny little things is 1 centimeter cubed or 1 milliliter. 1,000 centimeter cubed is equal to a liter. So milliliters is 1,000th of a liter. It's a unit for measuring volumes, same as 1 centimeter cubed. Centimeters, we all know centimeters, we don't need to go through that. Density is mass divided by volume, the ratio of mass to volume. And length times width times height is the way that we can find a volume of a regular shape. So if we have cube or cuboid or something, we can do it like that. Liquid displacement, that's when we measure the volume before we put the object in, we measure the volume afterwards. That tells us what the volume of the object is. Density of water is around about 1 gram per milliliter or 1 kilogram per liter. So that means if you have 1 liter of water, it has a mass of 1 kilogram. It's very easy to get weight and mass wrong. If I have 10 liters of water, it will have a mass of 10 kilograms. 1 cubic meter of water weighs a metric ton. Objects floats in water. Okay, if the density of an object is less than the density of water, grammar on that one. Matter is just anything that occupies space. Physical property can be observed or measured without changing the substance. And finally, relative density means comparing the density of one object to that of another. An example of that is sinking or floating. I'm going to do a match now. Oh. Density of water is 1 gram. The density, mass amount of matter in an object, cubic centimeters, unit for there, centimeters for here, and density for there. And it looks to me like Jake's already got in there and taken the top spot. Could people try and beat Jake, please? And don't go on to it yet. I just want to just quickly show you how it works. So what you can do with this is you can have a look. So this is the density. They're using kilograms a liter. That's actually the same thing as grams per centimeter cubed. It's the same. And we can see the different values. Oh, sorry. So you can see the different values that we actually have for different substances. So if I look at aluminium, has a density of 2.7 kilograms per liter. That's less dense than titanium and way less dense than steel. Now I have an aluminium bike. I've also got a titanium bike and a steel bike. And for the same size, we can see that the steel bike, if it's the same volume, probably is right. If it's the same volume, the steel bike will be much, much heavier. So if you're looking at, I know a few of you are BMXers, know how to BMXer, steel tends to be very heavy, but it's also very, very strong. And so steel is often used instead of aluminium because it's actually much stronger than aluminium. The second thing about steel is steel has a bit of flex to it. So if you ride on a steel bike, It's never as harsh a ride as an aluminium bike. Titanium sits between the two of them. It's much lighter for the same volume than steel, so it's got lower density, but and still got a bit of spring to it. It's actually also insanely expensive frames because, and that's mainly to do the welding. It's very hard to do the welding. So that's what the density is. So when we do this, we can have a little play with this. We can look at the density. We can look at a styrofoam block. Okay, so this is 0.15 kilograms a liter. Water, remember, is 1 kilogram a liter. So if I drop this in, will it float or will it sink? Well, it floats. What happens if I pull it underwater? It bounces up. If I want to measure its density, okay, I have a mass for it. To measure its volume, I had 100 liters to start with. When I pull it underwater, 105 liters. So my volume is the difference between the 100 and 105, which is 5 liters. So if I were to do 0.75 divided by 5, it would give me 0.15 at one. So that's just one, just so you can play around with. You can also compare things. So we can compare aluminium. We can see what happens if we do wood. Just have a little play with that. Okay, so what we have is we've got a formula. Density is mass divided by volume, or shared with volume. And there's a couple of things I want you to notice about this, is that mass, remember, it's the amount of matter in a body, is measured in grams or kilograms. And what we have is volume is measured in centimeters cubed. So when we actually want to know, well, what's density measured in? Well, I can divide those two in the same way. So I can say, well, density is just grams per centimeter cubed. And per, I think some people haven't actually really understood this properly. Per effectively means divided by. So if a question ever asks you what's the density and it gives you G per centimeter cubed, you can immediately go, well, it's got to be that G measures mass. It has to be mass per divided by, shared with, and we know that is volume. So if I know the units, I can work out what the equation is. Now, some of you won't get that, but some of you will, because some of you are going to do extremely well at GCSE. So if I want to know, then I want to say, okay, so that's what density is. Well, what's mass equal to? Well, I'm going to have to change this formula, but I want to show you something a little bit different first. I'm going to teach you a little bit of English. It's probably grammatically incorrect because my English isn't the best, which probably should be. And the first sentence here, the cat sat on the mat. Okay, so let's just change that one. The cat sat on the mat. I'm going to do something called change the subject. And the subject is the mat is where, oh dear, I'm in trouble now because I can't do the thing, where the cat was sat. I'm going to change the subject again. So the subject went from being the cat to the mat. Sitting, so this is now the subject. Sitting is what the cat was doing on the mat. So I've changed the subject, the cat, the mat, the sitting. It's all been changed, but guess what? It all means the same thing. Okay, so that's what's called changing the subject. So when I go to looking at my density formula, what does mass equal, question mark? Well, let's just have a look at how we would change the subject for that one. So I start with density is equal to mass over volume. And the way I look at it is going, right, well, what's stopping mass being on its own? So what's stopping mass being on its own is this volume. I need to get rid of that. And the easiest way to get rid of it is to times top and bottom by volume. So if I do mass times volume here, then it goes. In the same way, if I multiplied a half by 2, the 2 disappears. The 2's gone. But if I've done something to one side, I have to do the same to the other. So that's going to be volume times density. Okay, so that leaves us with mass is equal to, let's just put that out, volume times density. This is algebra that you must love from maths. So what does volume equal? Okay, get yourselves a pen or a pencil. Actually, no, you don't need to. You can do this in chat. Tell me what volume equals. So it's just going to put into it, does V equal, we'll call for density, let's call density D for now. Does V equal MD? Does V equal M over D? Does it equal D over M? Here. And so we've got same mass, same volume, same density. We can have a look at this. So if they're the same mass, then we should know that the bigger ones, bigger volume ones, would be less dense. So the big one is more likely to float, and the small one with the same mass, just knock them in, are likely to sink. When I look at the same volume, they're all the same volume now. So for that volume, which ones are more likely to sink? Think for a moment. Okay, the heavier ones are more likely to sink than the lighter ones. If they all have the same density, then if one of them floats, what can we expect the others to do? They'll all float as well. And if they have the same density, if something has twice the mass, it would also have twice the volume. So I want to know, do you understand that? And I'm going to give you another test. Okay, let's just have a look and see what that test is. So we need to do quick things of answering these questions. Not many of them. We only have 5 minutes to do it in. Okay, at the bottom here, there's mystery. And in the mystery, we have to try and work out what these things are. And